Hey guys, how are you? This is Mr. Lewitt. Excuse me. This is Mr. Lewitt, and we're going to make another short, or I'm going to make another short video today. I'm afraid I don't have time for a really long video. This video, I'm going to try to keep it to about, 30 minutes, maybe 35 or 40 minutes, but that's it. And then I've got some family stuff to do. I got to take care of my dog. I got to take care of my mother. So, yeah, I've got a lot going on today. So, but yeah, so let's get going here. So let's talk about chapter 3. Um, let's take a look at the first question. It says here, identify the steps used. Here, let me make my screen just a little bit brighter, just a teeny bit brighter. Okay, I think that works. Okay. Identify the steps used in algorithm 1 to find the maximum element in the following finite sequence. So we have a list of numbers here. We have these numbers right over here. Okay, we have 1, 8, 12, 9, 11, 2, 14, 5, 10, and 4. And we want to find the maximum. It looks like the maximum is 12. I think it's 12. Okay. So let's see. The first thing we would do is, okay, maximum. Let's see. We start with 1. Maximum is 1. And the next step is, let's see, I is 2, I is 3, the max is 8. So the new maximum is 8. And then the index, these are indices, index 4, 5, 6, 7. The next maximum is 12. Oh yeah, sorry, the maximum is 14, right? And then the next maximum is going to be 14. So okay, so this one, well, let me see here. Hold on one second. Okay, so you know what? It's going to be this one right over here. And the reason, okay, the reason is because I started index 1, well, in most programming languages, this is really index 0, but I think in your book they started index 1. You started index 1, you go to index 2. The maximum is now going to be 8. Then you go to okay, index 3. Well, at index 3, the maximum should really be 12. I don't know why they're going this far. Hold on one second. You know what? This is kind of a tricky one. It's either going to be this one or this one. The way they're writing the answers is a little weird. It's a little bit weird. Okay, so yeah, this is a little bit confusing because of the way that they're writing it. But basically you start with the maximum is equal to 1. And then at index 2, 8 is bigger than 1, so the new maximum is 8. Then you go to index 3. I don't know why it's necessary to go all the way to 4, 5, and 6 because, oh, I see, because the next maximum is 14. Okay, so this is index 3, 4, 5, 6, 7. Yeah, I see what's going on here. So, and then at index 4, 5, 6, 7, you have a maximum, right, 12. And then here at index 7, the maximum changes to 14. Okay, so this is how they're doing it in your book. This is how they're doing it in your book. And there's nothing wrong with this. It's okay. Let me show you what I think is a better way of solving a problem like this using Mathematica, okay? So let's see. what should I call it? So find maximum. Hope you guys can see that. Maybe I should make it this just a little bigger. Okay. Find maximum. We need a list that contains at least one element, all right? So the x underscore means we just have one element. X represents one element. If you see something like this, or this, or this, or this, I don't care what letter you use, okay? Or you could use several letters, it really doesn't make a difference. That single underscore means that the variable represents one value. If you see something like this, okay, that means one or more values. X represents one or more. And if you see something like this, all right, that means that X represents 0 or more values. Okay, this means one value, right? This means one or more values, and this means 0 or more values, and it really does make a difference. It really does make a difference, okay? And like I said, it doesn't have to be X. It could be, you could use T, or you could use many letters. You could use cat, I don't care what, you can name your variables whatever you want to name them. It's not an issue, okay? As long as your variable names do not conflict with built-in function names, because that would be a problem. That would be a problem, okay? So you can't find the maximum of an empty list. Excuse me. Okay, you can't find the maximum of an empty list. So you need a list with at least one element, usually a number, one number, okay? So the maximum is obviously just going to be X, right? Okay. And what if we have more than one element? What if we have more than one element? So then that's going to be, we have a number here, right? And then let's say this represents 0 or more values. X is one value, and X's represents 0 or more values, okay? So what that's going to do is this, all right? We're going to create a module. Maximum is equal to find maximum X's, okay? If X is greater than the maximum, all right, maybe I should call this maximum of X's, or whatever you want to call it. If X is greater than the maximum of X's, then give me back X. Otherwise, maximum of X's. Okay? And yes, this is a recursive function definition. This is a recursive function definition. So let's see if this works. Find maximum. Oh, let me see. 18129. 18129. 11.2.14.5. 11.2.14.5. And 10.4. 10.4. Like, that's what truck drivers say to each other. 10.4, good buddy. Something like that, right? Okay. Ooh, what just happened over here? This isn't so great. Whoa. Yeah, this has to be in list braces. That has to be in list braces. Shift enter. There we go. So now the answer is 14. We know that the answer is 14. Find the maximum of 1, 8, 12, 9, 11, 2, 14, 5, 10, 4, and we see that the answer is 14. Okay? So this is a recursive function. The way they're doing it in your book is not recursive. They're doing it through mutation and iteration, which is the way people normally do it, like in C, C++, Java, Python, you know. But this is a more mathematical way of doing it. All right, this is a more mathematical way of doing it. And yes, there are for loops in Mathematica. There are for loops in Mathematica. You could do this. You don't need to do int I, okay, because this is not a statically typed language. So I is equal to 1, I is less than or equal to 15. Let's see, print toString I, string concatenation, I love recursion and functional programming. Oh, that's a little too small, so we need to change that a little bit. Okay, style. Let's say font size is 24 and font weight is bold and font color is blue and font slant is italic. So there we go. I love recursion and functional programming, and if we want to, we could do let's see, what else can we do to make it more interesting? How about semicolon, pause for 0.3 of a second. Okay, so when you separate commands like that, and the commands are supposed to be part of the same block, you need to separate them with a semicolon. All right, shift enter. Oh, wait a minute. Why am I getting a lot of nulls? Now that's not too good. What did I do wrong? Hold on 1 second. Close the print. I see. Pause for 0.3 of a second. Close the for loop. There we go. Okay. So yes, there are, excuse me, there are for loops in Mathematica. I'm going to be quite honest with you guys. A lot of Mathematica programmers don't use a lot of for loops and do loops and while loops. They're used sometimes, but Mathematica uses the functional paradigm of programming. And the functional paradigm believes in certain things. And in general, functional programmers use recursion in order to do looping. They use recursion to do looping. So yes, you can use a for loop in Mathematica, right? You can, but it's not something that's done a lot in Mathematica. Generally, they prefer to use recursion. And of course, this is an example right over here. This is an example of a recursively defined function. This is a recursively defined function, okay? So, yeah. Okay? How are we with time? Okay, 15 minutes. So what I would like to show you, let's go over a sorting algorithm, which is sort of related to what we're doing here. And actually, let me see here. Yeah, let's go over a sorting algorithm. Analyze for properties of algorithms. Okay, this one's pretty easy. Not quite what I'm looking for. Well, this is a pretty easy problem. We're supposed to just add up the numbers. Let me see. Add up the numbers from 0 to 10. Okay, so once an answer is submitted, you will be unable to return to this part. Identify which characteristics of an algorithm the following procedures have and which they lack. Select the characteristics that the procedure have and leave characteristics unselected that the procedures lack. Well, we have okay, so the way that they're doing it in your book, there should be a return statement. Okay, although you don't need it in Mathematica, but you do need it in Python, and you don't need it in Rackets. So there's going to be, what they're missing here is return sum. Okay, but in Mathematica, you don't need it. All right, you don't need it. So it says here, procedure sum. I want to add all the integers, all the positive integers from 0 to some positive integer n. In this case, n is 10, while I is less than 10, sum is equal to sum plus I. And there's another problem going on here. I was not initialized, and yeah, I is not initialized, and then sum is mutated, but I is never mutated. In fact, I is never, I is not initialized, and I is never mutated. So this function is kind of, it's a crappy function. It's not going to work. So input, the function has input. There's no output. It is actually, this function is not even finite because I is never initialized or incremented, so the function is not finite. And as for definiteness, that's tricky. That's a little bit tricky. There's definitely input. The input is right here. Let me see what they say. Let me see what the authors of your textbook have to say. Yeah, the authors of your textbook agree with me. This function's pretty crappy because it has input, but it doesn't have anything else. It's certainly not finite. This function's going to run forever. The while loop is going to run forever because I is never initialized, I is not incremented, and there's no return statement. Now let me show you how to do this in Mathematica, because in Mathematica it's very different. It's very, very different, okay? So let's give this a whirl. Excuse me. Okay, I've got a case of the yawns today. Sorry, it's a sleepy Sunday. So I'm going to write a Mathematica function that will add up all the integers from 0 to some positive integer n. Yeah, that's fine. Okay. So let's get started. Well, if I have an empty list, everyone agrees that if you have an empty list, the sum is just going to be 0. Shift enter. Okay. Now, what if I have a list? What if I have a list that has one or more elements in it? What if I have a list that has one or more elements in it? Now remember, guys, this is going to represent one number. That's one number. And this right over here represents 0 or more numbers, okay? 0 or more numbers. Okay, so this is what I'm going to do. It's going to be x, oops, sorry about that, x plus the sum of x's, and that's it. And notice there's no return statement. There's no return statement. There is no return statements. In Python, you better use the return statement, but in Racket, you don't have to use return, and in Mathematica, you don't have to use return. In Mathematica and Racket, return is rarely used. Rarely. It's only used when you're trying to break out of a function. You're trying to break out of a loop early, prematurely. Otherwise, forget it. It's not necessary. So let's see if this works. Sum 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's 55. 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10, and that gives me 55. Now, what I would like to do is generalize this function. Let's generalize it. So let's write, arith, an arith function. Arith function. And this is going to be a little tricky here. My arith function will take, I'm trying to generalize some. Well, should I try this, or maybe this will get too confusing for you guys? Let's keep it simple. Okay, I'm going to write another function called product. The product of the empty list is 1. And the product of a list with one or more elements is going to be x times, instead of plus, it's going to be times the product of x's. So what is the product of 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10? And 10. Let's see if it's true. 1 times 2 times 3 times 4 times 5 times 6 times 7 times 8 times 9 times 10. There you have it. Okay, there you have it. This is obviously factorial, right? This is factorial. This is 10 factorial. 10 factorial. 10 factorial is the product of 10, times 9, times 8, times 7, times 6, times 5, times 4, times 3, times 2, times 1. Okay. And we could use the product function in our factorial function. Okay. So factorial of 0 is equal to 1. Factorial of 1 is equal to 1. And the factorial of a number, if the number is less than 0, print your argument must be a non-negative integer. And we could stylize that so it looks a little bit nicer. Font size is 24. Font color is blue. Font weight is bold. And font slant is italic. And factorial num, if num is greater than 1, and that's simply going to be the product of the range 1 to num. So let's see if this works. Factorial 0 is 1. Factorial 1 is 1. Factorial 3 is 6. 3 times 2 times 1. Okay, or 1 times 2 times 3, same thing. Factorial -7. Your argument must be a non-negative integer. Factorial, well, 1/2 isn't going to work, right? 1/2 isn't going to work. So Mathematica returns the expression unevaluated. So we could actually add another clause. How about head of 1/2? It's rational. So what we could do, let's see, insert, oh, no, that's not what I want. Okay, no. Well, yeah, let me just erase this line. Okay. We could do factorial num. The head of num is rational. Oops. So then we could say, let me see, I'm going to copy and paste this. Your argument must be an integer. Fractions not allowed. Okay, so let's try this again. Oops, here we go. Let me erase this. Hold on one second. So your argument must be an integer. Fractions not allowed. So basically, I'm narrowing down, I'm narrowing down the domain. The domain includes only 0 and positive integers. No fractions, no decimals, no fractions, no decimals, no negative integers. I'm just curious to see what is the type of 1.33334. Oh, so we have to cover this case as well. So the head of num is equal to rational, or the head of num is equal to real. I think that looks a little better. Let's give it a shot. All right, so let's try this again. Factorial of -7, not allowed. Factorial of 1/2, not allowed. factorial of negative 100 thirds, not allowed. Factorial of 1.33334. Oh, that's not too good. I'm getting an answer, but I should not be getting an answer. Let me see. Do I need parentheses? Yeah, I'm still getting an answer. So maybe, okay, that's interesting that Mathematica is doing that. So, very interesting. Hold on a second. Okay, so what I'm going to do is leave this. I'm going to copy and paste. Okay. Let's try this. Okay. Let's try this again. Yeah, that's interesting that I'm still getting that. Let me... interesting. Let me... I find that really interesting. How long is the video becoming? Oh, okay. I need to get going pretty soon, guys. Let me go up here and... Okay, remove factorial from memory. And then we're going to do this. Actually, I don't think we really need this clause, but I'll put it in there anyway. And Shift Enter. Oh, I see what's happening. It's because num is greater than 1. Okay, so you know what? I think I see what's happening. So we're going to, okay, remove that for the time being. Then we're going to do the case where num is rational. Then we're going to do the case where num is real. And then we're going to do the last case, where none of these other cases match. Num is not real, it's not rational, it's not negative, but it's greater than 1. So here we go. And so this one is questionable. This is questionable. There we go. Your argument must be an integer, fractions not allowed. So yeah, so there's a pattern matching thing going on here. There's a whole, you have to watch out. The order in which you define your function statements does really make a difference. It really makes a difference. So let's erase this stuff, guys. Let's erase it, erase it, erase, 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 erase. Okay, there we go. Okay, so we have these two cases right over here. Factorial of 0 is 1, factorial of 1 is 1. What happens when the factorial of num is negative? Sorry, your argument must be a non-negative integer. What happens when the factorial of the head of num is rational? Sorry, your argument must be an integer. Fractions not allowed. Okay, what happens when the head of num is equal to real? Sorry, your argument must be an integer. Fractions not allowed, or we could say decimals not allowed. So remove factorial again. Let's redefine it. Okay, shift enter, and we could do shift enter, decimals not allowed. Decimals not allowed. And then finally, the proper case is defined last. So factorial of 0 is 1. Factorial of 1 is 1. Factorial of 2 is 2 times 1. Factorial of 3 is 3 times 2 times 1. Factorial of 4 is 4 times 3 times 2 times 1. Factorial of 5 is 5 times 2 times 3 times 5 times 4 times 3 times 2 times 1. Okay, what about the factorial of negative 5? No, your argument must be a non-negative integer. What about the factorial of 2.3? Your argument must be an integer. Decimal is not allowed. Factorial of, well, we would have 2 plus 3 tenths. So this is the same thing as 20 tenths is 2. So 23 tenths. 23 tenths, which is 2.3. Your argument must be an integer. Fractions not allowed. So what am I doing here? This is actually exception, one second, exception handling. I am actually doing, one second, exception handling. I'm dealing with unacceptable inputs. Okay, how are we with time, guys? I'm gonna have to really get going soon. What if I want a list of factorials? Table, factorial k. K goes from 0 to 30. Oh. Okay, so the factorial, this is the factorial of 0, the factorial of 1 and 2 and 3 and 4, the factorial of 5, 6, 7, the factorial of 8, 9, 10, 11, etc., etc. And this is the factorial of 30. For this, you would use the table command. You would use, this is optional. You don't really need to table form your output. But to get a list of all the factorials from 0 to 30, you would use the table command. Okay? So table, k times k, k goes from 0 to 40. Okay, 0 squared, 1 squared, 2 times 2, 3 times 3, 4 times 4, 5 times 5, etc., etc. Okay? And the same with factorial. Factorial of k. K goes from 0 to whatever, 0 to 50. Okay? What if we start with negative 1? Right? So if we start with negative 1, then we can see there's a null value at the beginning of our list. So this is 0 factorial. Okay? And this is 1 factorial and 2 factorial, etc., etc. Okay? But because I'm starting my list with an exceptional value, a value that is not allowed, I'm going to have null at the beginning of my list. Let's try it again. Table, factorial of k. K goes from negative 1 to 20. Let's see. My factorials list is equal to, yeah, that's fine. Notice, this is not part of the answer. This is just a side effect. The printout to the screen or the printout to the console is just a side effect. This is the answer. My answer is actually my factorials list is right over here. And notice that the first value is null. Why is the first value null? Because I'm starting with negative 1, which is not allowed. Why is it not allowed? Because it is a negative value. Your argument must be a non-negative integers. What if I were to start this with negative 3? I would end up with 3 null values. 3 null values and 3 printouts. And this, again, I would have, 3 null values. Now, what if I want to get rid of those null values? My factorials list, start with the 4th element and go all the way to the end. Okay, but then I need to update my factorials list. It hasn't really changed. So what I would need to do is my factorials list is equal to my factorials list starting with the 4th element and going to the last element. And now I was able to get rid of the first 3, those first 3 null values. Okay? So we spent a lot of time talking about Mathematica. Okay, so Mathematica, guys, Mathematica is not Python, it's not Java, it's not C, and it's not C++. It follows different rules. Okay, it follows different rules. Mathematica has certain things in common with Python, but it's really not the same as Python. Okay, Mathematica in some ways is actually a little bit more like Racket, but it's not even Racket. It is what it is, it is what it is, okay? So, yeah, I'll try to make another video going over some of the chapter 3 material because there's a lot of stuff in this chapter. There's a lot of cool stuff in this chapter. But I really, I made the video mainly to show you Mathematica. Because I really want you guys to try to spend some time, learning Mathematica because you are going to use it. You're going to use it at the end of the semester for, maybe one or who knows, 2 of your programming projects. Okay, I mean, guys, you can't program the factorial function because guess what? I already did that for you, but maybe you could program something else. Okay, guys, I really have to get going. I have to drive my mother to the store. I have to walk my dog. I have a whole bunch of family stuff that I have to do, and everyone's waiting for me, so I really have to get going. Okay, so I will upload this video to YouTube later on. I will send you the link, and hopefully this will be a good, hopefully here are the functions for you to look at. Hopefully this will be, a good learning video for you, okay? So we did quite a lot. We did a for loop in Mathematica, the find maximum function. We did the sum function, the product. We did, the factorial function, a little exception handling. We did a whole bunch of stuff. Today, and actually kind of a short period of time. Okay, so all right, guys, that's really enough. And questions, just email me and I'll try to help you out. Okay, take care, and that's it for now.